Hi, Algebra 1. This is going to be our last chapter of study. So we're going to be taking a look at quadratics and parabolas and solving and graphing, which is very exciting, but it's going to put all of our ideas together here. Okay, so let's take a look at page 1. Modeling with parabolas. Okay, I don't know if you've ever heard this word before, but a parabola is a shape of a graph, a U-shaped graph. It's going to have the shape that is a curve, like a U. Okay, the parabola could be opening up or it could be opening down. So this is what we're going to be studying this chapter, parabolas, U-shaped graphs. Let's just show the difference here. Okay, you could have a linear model, and that would be if you are adding or subtracting. Adding or subtracting. And so the equation for that was y equals mx plus b. Okay, and m was the slope, or that was the repeating value. The repeating value. I keep adding 2, up 2 over 1, up 2 over 1. Okay, and so this right here, this is your initial value. Your initial value, we could say the starting amount. I know that we did this back in chapter 6. We start with a certain amount and then we add some more, add some more, add some more. Okay, and that would be like the beginning of time. What does a graph look like when you're adding, subtracting? What do the linear graphs look like? Okay, so here's two different types of graphs. If I have so much money in the bank, here's my money, my starting value, that's the y-intercept, but then I keep adding. So when you're adding, you're going to be increasing, you're going to be going uphill with a positive slope. Okay, and here's the b value. There's the starting value. Adding means m, slope is positive. Maybe you have a graph like this, okay, but you're subtracting or you're decreasing somehow. Okay, so if you're decreasing, you're going to have a starting value of b, but then everything's going downhill, downhill. It's decaying, it's going down. Okay, and so this m, which is the slope, would be negative. Okay, we did do exponential models. Okay, and that is when we are multiplying or dividing. Okay, and I remember when we studied this, we were multiplying. The bacteria in the petri dish were multiplying. They were doubling every day, okay, or getting halved. The equation for that was y equals a times b to the x power. Okay, and your a was your initial amount. That was your initial amount. And then the thing that kept getting multiplied, okay, was the b. So this is the thing that you keep multiplying. This is the multiplying pattern. The multiplying pattern. Okay, or maybe the halving. Then the multiplied number would be a half. Okay, but if you keep times by 2, that's the thing that gets the power. Okay, and then what do these graphs look like? There was a couple ways that they could look. Let's do the growths. Okay, so if the pattern was exponential growth, that means away from the x-axis. So as time was passing, higher, 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 exponential curvy. Or maybe time was passing and the roots were growing underground. Okay, the important thing is here's the x-axis and the graph was growing away from it. And then we had exponential decay. And decay gets closer to the x-axis. Get closer to the x-axis. So I have a lot of M&Ms, but I keep eating them, and I have less and less and less. Time is passing here, and you get closer. You approach the x-axis, but you never touch it. And then same thing like this. Maybe it's getting closer, closer, closer to the x-axis. Okay, so that was a recap of linear and exponential. But today, we're going to start looking at quadratics. Okay, and what's the quadratic model all about? Okay. Something goes up, but it doesn't keep going up, up, up. It's not increasing, and my money's not growing, okay? It's like a baseball. I throw it into the air, okay? Then comes down. Uh-oh. I can't use a line for a baseball that goes into the air like that. Okay, I can't use a curve, or maybe something goes down, okay, and then comes up. Maybe you dive down into the ocean and then come back up to the surface, okay? And so either way, you're going to have a turning point. There's a point at which the graph changes from up to down. Okay, there's two very important forms of equations we're going to look at here. Okay, the first one is standard form. And they both have their uses. Okay, standard form is going to look kind of familiar to you. It's y equals ax squared plus bx plus c. Okay, we've done lots of work with that. The other form is vertex form. Vertex form is going to seem a little different, but it's very useful for when you're graphing. Y equals, we start with an A, just like over here, okay, but it's been factored, and it's x minus h, quantity squared, plus a k. All right, and so what I need you to know at this point with both of these equations, okay, I notice that they both have, okay, the highest power is 2. That's the highest power, okay? So we're not talking about a line. We're not talking an exponential graph that has an x. We're talking about quadratics. This is the quadratic model. The power has to be 2, not a 3, not a 1. Okay? And there's a couple ways the graph can look. I kind of showed you this right when we started. Okay, so let's draw the axes. We could have a parabola, okay, that is opening up. Let's switch to a green pen. Okay, so opens up. I have the parabola going like this, okay, and it opens up. Maybe something's diving down, down, down. A bird sees some food on the ground. He gets the food, okay, and then he turns back up. Here's a parabola opening up. I'm going to draw another one, okay. Here's a parabola. I'll draw it way over here. Down, 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 hits the surface of the water, and then goes back up, okay. Or maybe it's like a diver, okay. He dives down under the water, reaches the lowest point possible, and then after all the down, 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 that's the special point that he turns and then goes back up. Okay, get the idea there? Over here, I'm going to draw some parabolas that open down. Okay, and that's what we say. We say open down. Okay, so maybe what happens is I throw a baseball high, high, high into the air. It reaches the highest point, and then it comes back down. When you're drawing these, make sure you put some arrows on them. Okay, or maybe I have a parabola over here, and it goes high, high, high. That's the highest it reaches. I shoot a rocket into the sky, and then it comes back down. Okay, so those are parabolas opening down. All right, we're going to focus more on parabolas here. So let's turn the page. Okay, this first one here, the height in meters of an object. Okay, so here's the equation. Notice that there's a squared power. Okay, so this is definitely a quadratic. Okay, and they've drawn the graph. I don't see x's. Okay, so instead of x values, they've got t values. So the x-axis, but right here, is time. This is time. Okay, so time is passing 1, 2, 3. Time is in seconds. Here's 4 seconds. Here's 5 seconds. So the x-axis is time. And what is the y-axis? Let's go see. The y is usually here is an h of t. So what does the y-axis say? Height in terms of meters. So here's 0, here's 10 meters, 20 meters, 30 meters, 40 meters. You see how this is the height? So I notice here that the object, okay, starts here. Where does it start? At 100. The object goes higher, higher, higher. How high does it get? Does it get up to 200? No, it only gets up to 164, and then it goes back down. Okay, it hits the ground, and I don't know if it goes under the ground or what. What is the maximum height reached by the object? Okay, height is on the y-axis. So the highest it reaches, right there, 164 feet. Oh, I'm sorry, meters. Meters. It says meters right there. Okay. It says h, the height, is in meters. So when they said height, I know that I was looking for an h or a y number. Okay. Now the next question is different. It says, how long does it take the object to reach the maximum height? So here's the maximum. I'm going to call that maximum. How long does it take? Okay, now I have to study the x-axis, the time axis. How long does it take to get there? Let's see. 1 second? No. 2 seconds? Yes, 2 seconds is the time it takes to reach the maximum. 2 seconds. Okay. When does the object land? Oh, when does it land on the ground? When it says when, that means time. So let's see. Here's the ground right there. Okay, I'm going to put a little note, okay? That's hitting the ground. So let's see. 1 second, 2 seconds, 3, 4, 5. No, a little more than 5. Oh, look, they have the coordinates listed. I want the x value. The x value is the time value. 5.202 seconds. Okay, so we have to use our values. Look on your paper right there, it's really tiny. Okay, the object was originally launched from a platform. How high was the platform? Okay, can you tell me where it started? So I know that right here's the time. I have to go to time 0. Okay, time 0. Time 0 is the beginning, right? Isn't the beginning 0? That's 1 second of time. No, I want to go to the beginning, when it was originally launched. How high was it when it started? 100 meters. How long was the object above 100 meters? Okay, so here's 100 meters. I could see the object was higher, higher, higher than 100. That's the highest it got. Okay, here's 100. And the question is, how long was it? As it started going down, that's still more than 100. That's still more than 100. I got to go all the way to here. And that is when it hits 100 again. It starts going below 100. Okay, so this is all the time. How long was it above 100 meters? I'm going to write this in interval notation, I think. I'm going to say time is between 0 seconds all the way up to 4 seconds. Between 0 and 4 seconds, it was less than 100. Now here's another one. Let's get some more practice, okay? We're going to practice in class tomorrow too, just to get better. The depth in meters that a dolphin dives while swimming is modeled by the function. Okay, so we don't have a y, we have a d. D is the depth, so we've got height in meters. And then instead of an x-axis, we have a t-axis, which represents time in seconds. Okay, so this axis right here, here's 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Here's all the seconds. And then this is the height. Here's 0 meters, -10 meters, -20 meters. Do you see how it's going below -40 meters? What was the lowest the dolphin dives below the water? How low does it go? It dives down, down, down. Okay, and here's the lowest, and then it comes back up for air. Okay, so a lot of people are really good at finding the lowest. Here's the minimum. The question is, what's the right answer? Is the answer 4 or -100? When it says what is the lowest, I know my answer has to be so many meters. How many meters below? Okay, meters is the y-axis, so I got to pick the y number. Does it make sense that the number should be -100? 4 is the time. The correct answer is -100 meters. Part B. How long does it take the dolphin to resurface? Okay, how long does it take? So let's see, he starts right here, and then he's diving, 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 all the way until he's back at the surface. Okay, so how much time is that? How much time does it take? I want to look at the x-axis. 1 second, 2 seconds. Does it take 6, 7, 8? A little more than 8. It takes 8.472 seconds. Okay. Time, when it says how long, that's the x-axis. So grab the x number. At what time does the dolphin reach its maximum depth? When it says maximum depth, that means the minimum. That means the lowest. That means how far down did he go? All the way down to here. At what time? Okay, so your answer has to be so many seconds. I know this is the lowest it goes. But what time is that? The time is the x. So after 1 second, after 4 seconds, he's at his lowest. 4 seconds is the answer. The dolphin was swimming under the water before it started its dive. Okay, that makes sense. It was under the water. At what depth was the dolphin swimming before it started the dive? Okay, so if I go to the beginning, did it start at 0? Here's the surface line. Here's the surface. I'll put the water right here. No, it didn't start. It started down here, right? It started at -20 meters. Then started going down. -20 meters. At what time? At what time did the dolphin reach a depth of 80 meters? Okay, so first I got to see where's 80 meters. Is he at 80 meters here? No. Here? No. Here? Here's 80 meters. Here's the little dolphin. I wonder if I'm a good dolphin drawer. Dolphins have like a pointy fin, right? And then it goes like this. Yes, I am an awesome dolphin drawer. Yes. Okay, here's the little dolphin. When is he at 80 meters? When? Not 80 meters, but when? At what time? At 1 second? No. Is it 2 seconds? Yes. At 2 seconds. But wait, that's not the only answer. Is there another time that he's 80? Because then he goes down farther than 80. But wait, he needs some air. He's going to come back up. Is the dolphin ever at 80 meters? Yes. Once on his way down and once on his way up. What time is this? 3, 4, 5, 6. At 6 seconds, he's at 80 meters. Yes. 2 times, once on the way down, once on the way up. He's only at negative 100 one time. But everything else 2 times. How deep was the dolphin after 8 seconds? After 8 seconds. 1, 2, 3, 4, 5, 6, 7. After 8 seconds, where's the little dolphin? He's down here. How deep is that? Negative 20 meters. Okay, don't worry if you have some questions. We're definitely going to do this for a couple days and get a lot better at it. Thanks, guys.